Today, we're cracking open the playbook for one of the most powerful techniques in data science right now, creating synthetic data. We're going to dive deep into how you can engineer data sets that are realistic, powerful, and totally privacy safe, all from scratch, and all using Python. So let's get into it.
But hang on, why do we even need to make up data? I mean, isn't the world drowning in data already? Well, if you've ever worked on a real data project, you are probably smiling and nodding right now. You know the pain. You're all set to build a new feature or train a model, but the data you need is, well, it's either locked away, it's incomplete, it's full of sensitive personal info you can't touch, or maybe it just doesn't exist yet. It's a huge universal bottleneck.
And this slide just nails the problem, doesn't it? Over on the left, you've got your production data, the real deal. But it's often behind this wall of privacy concerns. You've got strict compliance rules like GDPR to worry about and just simple access restrictions. Trying to get the data you need can take weeks, and your project just grinds to a halt.
And this is where synthetic data comes in. It's the key that unlocks all of this. First, it completely solves the privacy issue because it's all algorithmically created. There are no real people in there at all. Second, it lets us simulate those weird, rare events or edge cases that might be missing from our real data. And maybe most importantly, it unblocks our teams, letting them build and test and prototype without having to wait around for access.
Okay, so how do we actually do it? How do we build this synthetic reality? We're going to put together a toolkit, a modular one, using 4 incredibly powerful open-source Python libraries. Just think of them as our Lego blocks. We can snap them together to engineer almost any kind of data we can imagine.
So here it is. This is the map of our little ecosystem. We've got scikit-learn, which is amazing for creating data with specific machine learning structures. Then there's NumPy for all the core math and statistical foundations. We've got pandas for handling the super important dimension of time. And finally, Faker for generating data that just looks and feels human. Each one of these has a really specific job to do.
Let's kick things off with the specialist in the group, scikit-learn. Now, you probably know it for its incredible machine learning algorithms, right? But what you might not know is that it also has these killer tools for generating data that's perfectly designed to test those very algorithms.
So check this out. This is MIC-blobs. With just a couple of lines of code, we can generate these beautiful, distinct clusters of data points. This kind of thing is absolutely perfect for stress testing things like customer segmentation or even image recognition algorithms. And you can even control the fuzziness of the clusters to see how your model holds up when the lines between groups get a little blurry.
And then there's make classification, which lets us take it a step further. Here, we can precisely control everything. How many of our features are actually useful, how many are redundant copies, and how many are just complete noise. This lets us engineer a very specific challenge for a model, so we can really test if it can find the signal hidden in all that noise.
Okay, tool number 2. Let's move on to the absolute foundation of everything we're doing, and that's NumPy. You know, if scikit-learn builds the complex structures, NumPy provides the raw materials. It's the engine that lets us create data that mirrors the statistical patterns of the real world.
And this is so important, because real-world data is never flat, is it? Things like human height, they follow a classic bell curve, a normal distribution. Ages might be more evenly spread out, or uniform across a certain range. And something like income levels, almost always weighted, with way more people in some categories than others. NumPy gives us these simple commands to sculpt these exact distributions, which makes our data feel statistically real.
All right, next up, pandas, the undisputed master of time. Think about how many data sets have a time component. Stock prices, user activity, sales figures, it's everywhere. And pandas is our go-to for generating really convincing time series data.
And this slide just illustrates the magic perfectly. We start with pure random noise. That's the gray static you see. It has no memory, no trend, nothing. But then, by applying a simple cumulative sum, QSUM, we transform that randomness into a story. Each new data point builds on the last one, and suddenly you have this believable random walk that looks exactly like a stock chart or a sales trend. It's so cool. Our final tool is Faker, and its job is simple but so crucial. Make our data look real to a human being. It generates totally plausible but completely fake names, addresses, emails, you name it, all that stuff we call personally identifiable information, or PII.
And just look at how easy this is. With just a few simple calls to the Faker library, boom, we can populate a user profile card that looks totally legit. This is an absolute game changer for front-end devs who need to test a UI,
or for anyone who needs to fill a fake CRM database without ever touching real customer data.
Okay, so we see all the individual tools. Now for the really powerful part, putting them all together. This is where we stop generating simple columns of data and start engineering a complex, interconnected, and truly realistic world.
And this right here is the secret sauce. Look, isolated random columns of data are basically useless for serious machine learning. A realistic data set has to have internal logic, right? Relationships between the columns. So what we do is we create a correlation engine using some simple math and NumPy. A person's salary isn't just a random number. It's usually derived from things like their years of experience and their education, plus a little bit of randomness, a bit of noise. By defining these formulas, we are literally building that internal logic into our data.
And this is the grand finale, the whole orchestra playing together. We can use Faker to generate a users table with names and emails. Then we use NumPy to create a demographics table with statistically sound ages and incomes, and we link them with a user ID. And finally, we use Pandas to create an activity log of what those users did over time. See? All three tools working in concert to build a complete relational mock database.
So we've got our toolkit, and we know how to combine the tools. But before you run off and start building, we need to cover the 3 golden rules of synthetic data generation. These will make sure the data you create is actually useful and not just junk.
Rule number 1, and this one is absolutely non-negotiable. Seed everything. By setting a random state or a seed, you're guaranteeing that every single time you run your script, you get the exact same random data. And why does that matter? Well, if you can't reproduce your data, you can't reliably debug your code or validate your model's performance. Simple as that.
Okay, rule number 2, map to reality. Your generated data has to actually make sense. Before you write a single line of code, ask some basic questions. What's a reasonable age range for my users? What does a plausible income distribution look like for this population? If you create a dataset where the average user is 112 years old, any model you build on it is going to be completely worthless. You have to sanity check your assumptions.
And finally, our third rule. Beware the perfectly clean dataset. I'm serious. Real-world data is a mess. It's got missing values, typos, weird outliers. It's chaotic. If you train your model only on pristine, perfect data, it's going to be brittle, and it'll break the second it sees the chaos of reality. So you have to be intentional about injecting some of that messiness back into your synthetic data.
To pull this all together, here is your high-value takeaway, your cheat sheet, the Synthetic Data Selection Matrix. Use this to pick the right tool for whatever you're working on next. Need complex data to test an algorithm? That's scikit-learn. Need to build in statistical relationships? Go with NumPy. Building a time series? It's gotta be Pandas. And for realistic text and UI mockups, Faker is gonna be your best friend, for sure.
So there you have it. You now have the complete playbook for engineering data. You've got the tools, you've got the strategies to combine them, and you've got the golden rules to guide you. The only question left is, what reality are you going to build first?